Hello, hello, hello. Thank you, everyone, for joining. My name is Leo Vasilou, and I want to thank you for giving us some of your precious time today. Welcome to 3 tips to supercharge your application tracing. We have prepared a very tactical, not your usual marketing fluff type of webinar, and we hope you enjoy the approach. Some housekeeping items before we begin. First, please enter any questions into the Q&A tab. We will respond to them. Second, please be sure to find the poll tab and respond to our poll at the end. Third, we will be sending a recording of the webinar after it's over, in case you want to forward it to a friend or a coworker. And having said that, please go ahead and navigate over to the chat tab and just say hello to other webinar attendees. We are joined today by Sarkan and Kelly. Sarkan, would you mind saying hello and introducing yourself?
Yeah, sure. Thank you, Leo. Hello, everyone. Hello again. This is Sarkan. I am the architect at Catchpoint Tracing product and working with engineering and the product teams. I have been working in tracing and serverless era for 7 years, and as a result of my continuous contributions, I have been nominated as Serverless Hero by AWS about 3.5 years ago. And yeah, that's all for me.
Thank you, Sarkan. And Kelly, would you mind saying hello to everyone?
Yeah, hello everyone. I'm Kelly Avina, Director of Product Management here at Catchpoint. And I'm very excited to join the webinar today and talk about tracing and how it relates to everything else you do with our Catchpoint portal.
Fantastic. Thank you, Kelly. And as I mentioned, my name is Leo Vasilou. I am the author of our annual reliability report. Now, tracing is a product in the Catchpoint platform. The overall platform is designed to help you stay ahead of issues in your internet and application stacks that may impact your personal productivity, your business operations, or even your business revenue. While tracing by itself, we believe is super cool, we believe there's a 1 + 1 = 3 type benefit when you combine tracing with other parts of the platform. So first, combine with service level objectives and service level tracker. This most certainly is not a webinar about SLOs and error budgets, but if you would like to learn more, then please be sure to answer the poll at the end or simply ping us in chat. Tip number 2, apply robust performance analytics. Faster apps mean faster money, but fast might be different to different users, especially given today's distributed and complex application architectures, which we'll get into. And third, know what's in the secret sauce. With features like time travel debug and trace linking, you'll be armed with confidence on why to use Catchpoint for tracing. So jumping right in, tip number 1, combine with service level objectives, budget, and tracker. Nothing crazy here. We're just gonna take a minute, set the stage for the conversation. Right, the internet stack are as important as electricity, but this webinar is about the application stack and tracing. So on the left, person hailing a ride share, they're in some urban setting, definitely not sitting next to your servers or your services in your clouds or data centers. And before they even get to your application stack, their request goes across the internet, right, which will be different in different parts of the world. Right, they hit the GPS, tag the location service, maybe DNS recursion says, hey, let's send them to this cloud or this data center versus the other one. And then finally, their request hits your application stack, which is a whole other array of components, also probably across multiple clouds, data centers, or third parties. And if your application stack is comprised of multiple services, for example, your product service, your checkout service, etc., those services are comprised of hundreds or thousands or more of underlying components. And then the question becomes, how the heck do you find errors when they occur, right? The proverbial needle in a haystack conversation. So before we continue, as promised, we wanted to give a sneak peek at some of the stats from the upcoming SRE report. Why? Well, because when we talk about our products, it's not about whether Catchpoint thinks our products are cool. It's about understanding what practitioners do and need in the field and giving them data so they can benchmark against other practitioners. So first, we asked in this year's survey, what indicators do you monitor or measure? And as you can see, the top two responses of uptime and availability and performance / response times coincide with the first two tips in the webinar. What a coincidence, right? And then second, in this year's survey, we then asked, are your indicators tied to any service level objectives? For example, if uptime is an indicator, do you have an objective of 3 nines of availability? Or if response time is an indicator, do you have an objective of 90% of responses must be less than 100 milliseconds, as just simple examples. So for us, it is refreshing to see that frequently and always dwarf other entries in the series. And it's also great to see that performance objectives are also as high as uptime objectives, right? Slow is the new down, as we often say. And so if we are monitoring and measuring our indicators, tracking them against objectives, what does that actually look like in our platform? Well, it looks something like this, taken right from our SLO tracker. At a glance, we can see the beginning of the month on the left side was way worse than the end of the month on the right side. So we see substantial errors. We're blowing through our error budgets in the beginning of the month, and we say, hey, let's take a look at tracing to see what the heck is going on. And enough of me talking, let's go ahead and take a look at micro demo number 1.
In the first demo, I'm going to show you how you can get help from Catchpoint Tracing product to troubleshoot the errors caused by your APIs or backend applications in your Catchpoint test. But before starting with the demo, I want to briefly mention about the sample application we are going to use for the tracing demo here. For this purpose, we developed a sample movie booking application in which you can select the movies and the sessions you want to go and then make your reservation. And based on this sample application and flow, for the first demo, we also have created a sample Catchpoint test, which is running periodically to test and verify the movie booking flow by, selecting the random movies and the sessions and then triggering the booking flow and then verify whether the booking is successful or not. So after the initial information, I'm switching to the Catchpoint portal, and in here you can see that the sum of the tests, Catchpoint test has failed. But before diving into the failed test, at first I want to start with the successful ones to show you the overall flow of the application. And when you go to the details of the Catchpoint test run, you will see there's a view trace button here, and this button is visible if your Catchpoint client and division has tracing enabled. And when you click view trace button, you will be navigated to the trace map page in the tracing portal, and then in this page you will be able to see whole flow end to end, starting from the Catchpoint test itself and passing through the application in this flow. For example, for this particular application, this API is triggered from the Catchpoint test through the reservation and ticket endpoints, and then talks to MySQL database to get or write some of the movie-related entities, reservation-related entities, and then send a notification message to AWS SQS, and then the notification service just picks up the message from the queue and then sends the notification email to the target person. And let me back to the Catchpoint test run details, and then I'm gonna select one of the failed ones, and we'll click the view trace button to see what's going on for that failed test run in the backend. As you can see that the Cinema application is requested through the ticket endpoint by the Catchpoint tests, and there are 3 requests to this application, to this service, and then the third one is failed. As you can see that there's a red circle icon here, and then the request is somehow the request is rejected by the bad request. And to understand the reason of the failure, we need to investigate the trace chart here. As you can see that there are 2 other spans with the red background, so this means that this span has failed. And to understand the underlying reason, I'm gonna select the one at the deepest level, and then as you can see that since the time travel debugging is enabled for this span, we are able to execute this function line by line until we get the exception here. So as you can see that we are throwing the application itself throwing the exception here because the calculated price has negative value, but instead the price cannot have any negative value. So let me play back and then jump into the calculate price function to understand what is the bug here and these results with a negative price value. First, we are calculating the price, actual price, by taking care of the seats prices, and then since a coupon is activated for this reservation, we need to subtract the amount of the coupon from the calculated price. So here you can see that the actual price is based on the seats is 180, and the amount of the coupon is 999. So normally we expect that the price will be 0 because it cannot have any negative value. But since the logic is, but the problem here is that since the code logic didn't establish a minimum price limit to prevent negative prices here, instead it just subtracts the amount of the coupon value from the calculated price. This just results with negative price value. So here, because we get the calculated price value as negative, the API itself rejects the request with the bad request status code. So here, with the help of the trace map, we were able to identify the problematic service or component in the whole trace flow, and then with the help of the trace chart and the time travel debugging feature, we were able to trace it back to the line of the code the error occurred.
All right. Thank you for the SRE report sneak peeks. It's nice to see that such a large value has been placed on availability and response time. These metrics have such an impact on our user experience that you showed us, Leo, which honestly, I think looks a little more like this. The application stack is such a complex system of distributed applications that it's really just going to keep getting more complex. And we need an easy way to dig into that complexity to find and resolve bugs, configuration issues, latency issues. So with tracing, that really lets us pinpoint and follow the request from the user all the way through the application stack. And as you saw in Serkan's video, in conjunction with your synthetic tests, you can quickly identify the root cause for that downtime, if not reducing, if not completely eliminating your SLO, your impact on your SLO. As part of your SLO monitoring, so referring back to that error budget slide that you showed, Leo, maybe you see that impact happening right away in the beginning of the month. You might want to look at your application's overall health. Here you can see the aggregate response time, errors of the application, as well as which endpoints are most time consuming or have the most errors. Or you may want to dig into specific performance analytics in different regions. Let's take wait time to first byte. The time from when the server receives the request to the time when it starts to send the first byte of response. This can really make or break a user's interaction with your application. I mean, I know my mom, 70-year-old, is cursing at her screen and vowing to never use that site again if it takes more than like half a second. So time to first byte is the primary gateway metric to indicate performance of the application on the back end. Let's take a look at how Serkan identifies a latency issue with a synthetic test and was able to review the traces to identify the cause of that issue.
In this demo, we are going to analyze latency anomalies caused by API in the Catchpoint test. Again, for this demo, we have created another sample Catchpoint test, which is running periodically to test the movie details page by selecting a random movie and then, fetching its details. And as you can see from the test run results, the first thing that catches our attention is there are some anomalies in the distribution of latencies. While some tests take around 3 seconds, some others take more than 5 seconds, close to the 6 seconds. And to understand why this significant difference occurs, I will first compare the test run details of these two test run examples, slow and fast, in the Catchpoint portal. And let me select one sample from the fast ones and then one from the slow ones. Okay, I'm gonna start with the slow one again. As you can see, to get the movie details in the step 3 took more than 2 seconds, and most of the time was spent waiting for the backend API call to return a response, and it took about 1.5 seconds. And when we check the fast one, we can see that we were able to get the details of the movie less than half second, and the backend API call just took about 80 milliseconds. So in order to understand why there's a significant delay in the slow test, we need to understand why the backend API call is fast in some tests and slow in some others. To understand the slowness in the backend API calls, I will first open the trace map of the fast and the slow test runs in the tracing portal and we'll compare them. So for the slow one, open the trace map, and then for the fast one, open the trace map 2 in the tracing portal. Okay. As you can see in the trace map for the slow API call, for the slow test run, there are about 260 times database access. But when we check the fast one, we can see that this number is just 12 times. So this means that while fetching the details of some movies, more database queries are executed compared to others. Therefore, we need to understand why more database queries are run for some movies. So far, thanks to the trace map, we have found that the reason for the slowness in the backend API is more database access. After this, thanks to time travel debugging, again, we will find out why some movies have more database access. And for that, I'm switching back to the slow one and selecting the backend API application. And as you can see in the trace chart, most of the time it's depend on the add-cast function. And also there are probably more than 100 database query under this function. And when we switch to the fast one, the fast API call, we can see that there is only 3 database call under the add-cast function. So to understand why there are too much database query for the slow one, I'm gonna use timetable debugging, and we'll re-execute the traced code execution line by line. And at first we are getting the IDs, the person IDs of the cast in the movie, and then as you can see there are 63 person ID, And then for each person ID, we are getting the information of the cast one by one by executing an individual database query. So as you can see, the problem here is that while finding casts in a movie, casts are queried from the database one by one with their person IDs. That is why it takes much longer to get the details of movies with a lot casts than the other movies with less number of casts. However, instead, as an optimization, the cast in a movie could be fetched in bulk with a single query. Thank you, Leo and Kelly, for talking about the two main use cases. I mean, the error troubleshooting and the latency analysis. And I'm going to handle the third one, the trace linking. Trace linking basically means associating traces that are physically separated but casually related to each other. And I will explain trace linking in 3 use cases. The first case is that the trace context may not always be propagated. You know, classical distributed tracing solutions rely on context propagation to propagate trace ID from one microservice to another. For example, passing trace ID through HTTP headers. But this allows trace information to be propagated without modifying the actual content of the message. However, this approach is not feasible for all the communication ways, especially for the event-driven ones. And unlike HTTP, certain services, for example, AWS Kinesis, do not inherently support a separate metadata or header section for each record where trace context can be carried. For example, let's say that there's a producer service which writes events to an AWS Kinesis stream or Kafka, and then another consumer service just reads the events from the stream and then process them. In this case, it is not for the AWS Kinesis service, it is not possible to pass the trace ID along with the Kinesis record, as there is no such mechanism like header, message attributes, or tags to propagate trace ID from one side to another. Here, propagating trace ID through traditional through original payload should not be an option because it might have many side effects. For example, the consumer might have a strict schema check, and then it might reject the payload if it has unknown properties. In this example, without trace context propagation, there will be 2 different traces. The first one is producer to stream, and the second one is stream to the consumer. And with trace linking, we can link those 2 individual traces to each other. And for the second case is tracing batched operation, which requires trace linking. So let's think of as such a scenario. Again, there are producer and consumer services, and the producer service sends a message to a distributed queue like AWS SQS or RabbitMQ, and the consumer service gets a batch of messages from the queue and then process them. Here again, there are two traces. The first one is producer to SQS queue, and let's call this upstream trace. And the second one is SQSQ to consumer, and let's call this downstream trace. And tricky point here is that the consumer gets a batch of messages, let's say that 10 messages at once from the queue, and then process them in bulk. And in this case, in fact, the downstream trace at the consumer service is related to 10 upstream traces from the producer service. And as you can see in this flow, it is not possible to represent these multiple relations with just a single trace ID. And the third case is the business transaction, which we will demo. Actually, it is not easy to explain the business transactions with just definitions. Therefore, I'm going to explain it through a concrete example or our sample cinema application, movie booking application. So let's say that I have made a reservation for a movie at 1 p.m. and then this action of mine created a trace for the booking. And then I realized that I have another plan for that time and updated my session, my reservation to 7 p.m. in the evening. And this is another trace. But later I was reminded that I have another plan for this evening, and so I cannot go to movie. And then I canceled the reservation. and this cancel action has its own trace. So as a result, in this flow, there are 3 different traces: one for booking, one for updating, and one for canceling. Without trace linking, those 3 traces will be shown individually without any correlation between them. But trace linking allows linking traces based on custom business logic, which is why we call this approach business transactions. In this case, those 3 traces can be linked to each other over the ticket reservation ID, and all the create, update, and cancel flows for that reservation can be seen in a single trace map as they're working on the same item, which is the reservation. And finally, I also mentioned that trace linking is very useful, especially for troubleshooting errors or even security issues, because it allows you to see the entire flow in the same picture with the history of actions up to that time. Okay, I think I talked too much. Let's see the trace linking in action. Let me play the video. At first, I'm gonna make a reservation for a movie. I mean, let's say the Miracle Club. I have selected the room and the session, and next I have selected my seat, B3, next, pay, and finish. So I was able to complete my reservation successfully, and then as a result of this action, I will be able to see the transaction related to these booking flow, and I mean these post requests. And when I click the post request, you can see that the whole flow triggered by this booking action is shown in the trace map end to end. For example, in this flow, this cinema application is triggered through the API ticket endpoint and interacts with the MySQL database to write or read some of the entities during this flow, depending on the business logic, and then sends a message to SQS queue for the notification, and then notification service gets the message from the queue and sends the notification email. And let's say that after some time I have reminded that I have to cancel my booking because I have another plans on that time. And when I cancel my reservation, this will trigger a cancellation flow in the application itself. And then I can see there's a delete request as a result of this action. And when I open the trace map of this transaction, I'm not only seeing the booking flow, but also the cancellation flow here. Because here, with the help of the trace linking API, I was able to link those 2 distinct traces each other as they are working on the same reservation record, same reservation item. The first flow, the first trace is for the booking, and the second trace is for canceling that booking. And even though those are 2 individual and distinct traces, with the help of the trace linking API, our tracing agent is able to correlate those traces to each other. So in summary, trace link API allows our users and customers to be able to link different traces to each other based on their business logic needs. And especially this is very useful by providing you the whole history of an action until you get an error, for example. Okay, let me mention a little bit about the hotel, about the OpenTelemetry. Without going into technical details, I will briefly talk about OpenTelemetry. I mean, how OpenTelemetry emerged, what it is it for, and its basic concept. I'm gonna start with how hotel was born. And OpenTracing and OpenCensus were 2 separate open source projects designed for tracing and metrics in distributed systems. However, those projects offer different approaches and APIs, so it leading to confusion and integration challenges for users. To address these issues, the OpenTracing and OpenCensus initiative decided to merge in 2019, and then OpenTelemetry was created. The primary goal of OpenTelemetry is to allow users to perform tracing and metrics in their distributed systems through a single, well-defined, and widely accepted interface. And this aims to standardize tracing metrics and logging processes, ensuring consistency and ease of integration across various languages and frameworks. Okay, let's a little bit talk about the benefits of OpenTelemetry. The first one is technology agnosticism and no vendor lock-in, because OpenTelemetry provides integration and compatibility across different tools and platforms without being tied to a specific product. And the second one is huge community support. OpenTelemetry is supported and continuously developed by a large community as open source. On the other hand, many commercial solutions, including Catchpoint, are dependent on OpenTelemetry components at some level and even making contribution as part of the community. And the third one is transparency and the security. Being open source, OpenTelemetry code is available for review and audit by anyone, which allows for community contributions in identifying and fixing security vulnerabilities and bugs. Finally, I would like to briefly talk about the trace, metric, and log data which are collected in OpenTelemetry, and also they are known as the three pillars of observability. A trace, the first one is trace. A trace represents a single user or system operation as it moves through various components in a distributed system, and each trace consists of multiple spans where a span is a named and timed operation representing a continuous segment of work in a system, like a call to third-party service API or database query operation. And the second one is metrics. Basically, metrics are numerical representation of data measured over intervals of time, as they are used to quantify the behavior and performance of a system, like number of requests, number of errors, number of failed requests, and the CPU usage and the memory usage. And the third one is logs. Logs are event records that provide detailed insight into what happens in an application or system. And as you know, a log entry usually contains information like timestamp, log level, messages, and sometimes contextual data about the state of the application or system at a specific point in time. And finally, I should especially point out that these three elements are correlated to each other to offer a more holistic view of what's happening in a system. For example, if a metric instance, a spike, indicates a spike in error rates, traces can be used to identify which requests are failing and why, and then logs can provide detailed error messages and state traces for those requests. Okay, thank you for listening to me, and I am leaving the floor to Leo.
Thank you so much, Sarkan and Kelly. But more importantly, thank you to everyone who decided to give us some of your time today. We would like to go ahead and open the poll. If you could kindly take a moment to navigate and answer, we would appreciate it. We will otherwise go ahead and wrap up this webinar today. We look forward to seeing and hearing from you again on the next one. If there are any closing questions or comments, feel free to type away. Otherwise, we can pause for a moment just to make sure nothing comes through in the last few seconds here. Going once, going twice. All righty, team. Let's see here. Let's just see. How do I access the poll? Is there a link? So if you navigate to the poll tab, sort of on the right side of your screen, you will have the option to select there. Alrighty, team. Thank you very much. We'll see you next time.